Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera to all of you. Today we're going to learn on the last chapter for CPE501 Capital Process Control course, which is the Selective and Override Control. Selective control and override control is one of the many types of the advanced control system. So these two types of controller usually being implemented for safety purposes and optimization considerations. Selective control and override control protective strategy is basically to maintain process variables within the limits. There are situations where the control loop should be aware of more than just one control variable. This is particularly true in highly automated plants, where the operator cannot be expected to make all the decisions that must be made under abnormal conditions. This includes the startup and shutdown of the process. Hence, selective control and override control being implemented to these highly automated plants. Selective control consists of the higher selector and also lower selectors. So what is the function of these selectors? The function of selectors is to measure one variable. It is used to pass on as the process variable to a feedback controller. And another function of the selector is to select the higher or lower of several measurement signals. The example of the selector controller can be seen in this figure. So the figure shows the reactor temperature control. Consider the plug flow reactor where an exothermic catalytic reaction takes place. The sensor providing the temperature measurement should be located at the hot spot. As the catalyst in the reactor ages or as conditions change, the hot spot moves. It is desired to design a control scheme so that its major variable moves as the hotspot moves. To design a control strategy that accomplishes the desired specification in the plug flow reactor, we need to choose the high selector in the scheme. So the high selector in this scheme selects the transmitter with the highest output, and thus the control variable is always the highest or closest to the higher temperature. The override controller is sometimes known as the constraint control. So what is the basic idea of the override control? So selects between the higher or lower of several controller output for implementation. Under normal operation, one process variable is the controlling variable, while under the abnormal operation, some other process variable becomes the controlling variable to prevent it from exceeding a process or equipment limit. The limiting controller is said to override the normal process controller. Figure shows the tank and flow control loop, so we can implement the override control in order to control the height of the tank. Under normal controller, level in a tank is at high H1. So if the liquid level drops to H2, it will cause cavitation at the pumps. It is necessary to design control schemes that avoid these conditions. Under normal conditions, the load selector selects the output signal of the flow controller to manipulate the pump speeds. The level controller is not connected to the pump because the level is not at an undesired state. As soon as the level drops below the set point on the level controller, this controller will slow down the pump by reducing the output. When the level controller output drops below the output of the flow controller, the load selector selects the output of the level controller to manipulate the pump. So level controller has override the flow controller. So basically, override and selective controls are widely used to handle safety problems and constraint problems. High and low limits on controller output are also widely used to limit the amount of change permitted. That's all for today. Thank you. Assalamualaikum warahmatullahi wabarakatuh.